The question we have today is Ferris wheel. So let me read out the question. There are n children who want to go on a Ferris wheel, and my task is to find a gondola for each child. Each gondola may have one or two children on it, and the weight of the gondola may not exceed X. I know the weight of everyone. What is the minimum number of gondolas needed for everyone? So in the input, we're given two integers, n and x, number of children, and the maximum allowed weight. And then the next line contains n integers, p1 to pn, the weight of each child. So it's pretty straightforward. I get my input of the info I need, and then my output is one integer, the minimum number of gondolas, as the problem asked. And let's look. N is relatively reasonable, 2 times 10 to the fifth. X, the weight is anywhere from 1 to 10 to the ninth. Okay, so it's decent, and I have an input and output. So what I do for this question is that I know that I either have ideally I would have want to have two child in every gondola unless there's one that is overweight, so then I would have one person inside. And I know that in this condition that my PI must be less than or equal to X. So I should be fine. So at least every child is definitely able to go on a gondola. So what I do here in the code, let's step over it, is I include the things I'm going to use, vector, and I might sort it, so I need algorithm. So then I make like the input faster with IO base, sync with studio, tie to make C in and C out faster. And that as the problem stated, I take the input in and X, I create a vector P, which I use to store. And then my next line is for loop, where I take the n input of the weights and that I input those weights. And then because I want to deal with like the best pairings of how I can maximize every two groups if possible, then I would want to sort it because I don't care who goes on first. I just care about how can I maximize the number of people I group. So now I would just put everyone on. So what I do here is once I get everyone sorted, then I have my two counters, left and right. Left is 0, R is n minus 1 is the last one. And then my count is 0. So I start with the while loop and I increment each of the things based on the best optimal choice. So for instance, if I know that my most left and most right can make a combination, then I would just decrease the one on the right, increase the one on the left, and it just becomes closer as I move along, and I increase count. Otherwise, I just move one side of it. That's to say the right-hand side. It doesn't matter. So I just move one counter for that. And obviously, by the end of it, if I pair everyone up, at the end, it'll exit the while loop, and I'll have my count no matter what. Each time I'm just putting people in the gondola by the rules. I obviously just definitely put one person that's more heavier, so that's the major constraint. And then on the left-hand side, the lighter ones. If I can fit one, great. If I can't fit one, then there's no other way I can deal with it. So I still increment the counter. And obviously, in the end, I return what my CNT is, which is my counter, and I would get the minimum number of gondolas this way. Guess this is just a typical example of a greedy algorithm where I'm just putting my constraint on like the people who are the heaviest so that like I get them in because I know I have to put them on. So I just put them on first. And if I can get additional people on, the lightest ones on, that's awesome. If I can't, then there's nothing I can do about it. So I just let them take that single gondola. So that's it for today.